for this for this for this PV modules, we can see that the maximum power has 165 volts in peak, and the open voltage is 43.9, and the voltage at maximum power point have a 35.7. Open circuit voltage is maximum power, maximum voltage, but normally have no mean because at the open circuit voltage the current is 0, so the output power is 0, and it's a maximum power output. The power at the maximum power point of this PV module is 35.7, and which means normally we have. And the short circuit current is 5.14 amp, but the current at the maximum power point is only 4.62 amp. So in generally, the cell efficiency is 15.9%, and the module efficiency is even lower, is 12.92. Cell efficiency means one small cell, the efficiency of one small cell, and the module efficiency is, for example, in this case is 72 solar cell connecting in parallel series to form a module. The efficiency is definitely lower than the cell efficiency because we need to consider the wiring or resistance losses during for the whole system. And typically, the electrical characteristic of 72 cells monocrystalline system modules. 72 cells are in series, and we just can briefly estimate if the one single solar cell have the maximum water output is 0.6, and is the module output voltage at the maximum power point should be 72 times 0.6 is half 36, around 36 in 6, and the average cell characteristic are approximately for just one solar cell, one solar cell, the VOC is 0.61 volts, and the short circuit current is 5.14 amp, and the maximum power point at 2.3 amp. So if the maximum power output is 2.3 amp and times 72 is around around 144 around something like that, and this one is even lower than the maximum power point at the peak. So here in this chapter, in this slide of PowerPoint, we go through, we have a very inside view of what is a solar cells and what is a solar cell module, and some key parameter of the solar cells. One is the short circuit current, and another one is the open circuit voltage, and one is power energy power conversion efficiency. And now is we can have a short break, and we will continue the course at 4 o'clock, 4 and 5, 4 o'clock in the afternoon, and then we can have a short break. Okay.
Okay. Thanks, Mr. Zhang. And we will have a short break, and we will back maybe after 10 minutes, maybe at around 4.
Okay. Okay. question. Ask me another question is, it is understood that this PV panel needs to be replaced after certain intervals, certain periods, as I understand. What are the negative impacts of this PV panel? Let's say with the panel to the environment. Can we recycle and reuse this PV panel? You may answer after this break. Okay, very good question. I'm not sure whether any one of the students know the life cycle assessment abbreviation for LCA for the solar cells. And we can only say that the solar cell is a clean, no pollution during its operational period, and normally lasts for 10 to 20 years. And the fabrication and the recycling of the silicon-based solar cells definitely will consume some energy. Sometimes will cause some pollution. For example, let's say that at the beginning, everyone knows that the solar cells are fabricated by the silicon. Then the silicon is actually we fabricate a high quality silicon from using the silicon dioxide and using the oxidation and the reaction to extract the high pure silicon. And in this period, we definitely need a lot of material and need to consume a lot of electrical energy to purify the silicon. This one is definitely a lot of energy will be used. And the material is normally silicon dioxide. This material is very abundant around the Earth, and of course we will have a lot of pollution, but we need to control it. The one obvious pollution is sometimes, especially some small manufacturing silicon manufacturer will just discard the silicon into the directly outside without any treatment. This will definitely cause earth pollution. The earth pollution will the earth closely contact with the silicon can no longer use it for agriculture anymore. This one is the soiling earth pollution. This one is in the fabrication stage of the silicon solar cells. And for this one is the silicon purification. And after that, we cutting the silicon purification, and after we dealing with a lot of the other treatment, we can fabricate the silicon ingot into the silicon slide and into the PV panel. In this stage, limited pollution will be produced, so we can almost ignore the pollution in this production, but we definitely will take a lot of consumer energy to produce these panels. So for example, if we take about 10 kilo, for example, we're using a 10 kilowatt hour to generate one small PV panel. Then if we can, and this PV panel is used for the power generation in its operational stage. For example, if we're using for 3 years, and after 3 years, this PV panel can generate about 10 kilowatt hour electrical power, which means the recycle time, energy recycle time for this PV panel is only 3 years. But everyone know we know that the operational time of the typical PV silicon solar cell will be 15 to 20 years, which means after the first 3 years, the remaining time, the energy produced by the PV panel are free and clean without any pollutions. In this stage, we can see that it will take about around 3.5 years to recycle all the energy used to fabricate this panel, and the remaining its remaining operational period time will be used to generate a pure green and environment friendly energy. So in this stage, we say, okay, that's fine, but we haven't the life cycle of the silicon solar cell hasn't finished yet. So after the silicon has reached its operational period, and we need to discard and recycle it, we need another energy to dealing with this one. So in this definition, we sometimes people still didn't consider, and people at this stage, people only consider the fabrication, operation, and for the recycling energy, they didn't consider into this because they cannot estimate how much energy and environmental pollution will cost. In my opinion, or in my experience, I think the recycling problem of the silicon-based solar cell is also similar to the first the purification. So maybe because first of all, you know that the silicon solar cells is not only fiber, it's consisted by the silicon, but we have a lot of metals. We using the cathode and anode as the aluminum and the silver for the cathode and anode of the silicon solar cells, and how to extract these metals from the silicon. This is a problem. So after we recycle this material, first of all, we need to separate the different materials of the silicon solar cell into different category, and the different category have different process. For the metal, it's fine, and for silicon, we need to reusing it. If we want to reducing it, we need to put this wasted silicon into the we need to purify them, and more energy will be used to do this. So in this period, I think another, especially the solar pollution, will be produced as well, and the so-called recycle time is not scientific at all. It's not so scientific because we cannot estimate the later treatment of the wasted silicon solar cells. And also the technology about the recycling on especially recycling in the silicon-based solar cell is very still in development. We have a lot of work to do. I think that this one can I think the description of the above statement should respond to Sonam's question. Okay, so then if you understand what I'm talking about, you can type something to tell me how's your feedback, or are you satisfied with my answer? Okay, so now let's move on the PowerPoint. Yeah. After we go through the detail of the PV module, we can talk about the grid connected system. Grid connected system is yes, normally there are two categories of the BIPV system, or whatever BIP or PV system. There are one standalone system, standalone PV system. Another is a grid connected system. there are literally two different systems. Standalone system stands for standalone system do not connect to the grid at all. So the power generated by this system can be used by the local electric load by themselves. And normally the standalone system is used in area with with no grid or with a very remote area which cannot access the grid at all. But sometimes, for example, in some developed countries like Japan, Germany, Netherlands, and so on, European, especially in European countries, most of the grid is very wide, and sometimes the householder can install the PV panel on the rooftop, as we said in the previous section, and the PV generated power can be used by the household by themselves. The actual PV generated power can be resold to the grid and for resell to the grid. So the grid, the electric grid by itself is can access a storage as a storage, but the time is I'm not sure about the renewable energy policy of in Southeast countries, but there is the renewable energy penetration ratio should be no more than I think no more than 40% at the maximum, because even though we know that the renewable energy such as solar and wind energy is very friendly, but they have its intrinsic disadvantages such as unpredictable and unreliable and uncontrollable. This means because, for example, in sunny day, the PV panel can generate a lot of power, but how about the raining day, overcasting day, and at night? In this above weather condition, the solar panel cannot provide nominal power output. Then how to provide if for example, if the renewable energy penetration ratio is higher than 40%, which means at least 40% of the energy are provided by the renewable energy, such as the solar and wind energy, then the remaining are provided the traditional coal-firing plants or something like that. So if sometimes in some extremely weather condition, the total 40% of renewable energy can only output only half of them. For example, 20% of the designed penetration ratio. Then how to supplement the 20% gap? Can we using the traditional coal-firing plants to supplement the gap? So I think the new direction or the new development direction of the renewable energy is not the power generation part, but is the energy storage part. So I believe in most of the Lancang River and the Mekong River, we should have a lot of supplies for hydro power storage system, hydro energy storage system. For example, we all know the solar panel, solar system cannot provide any power during the night, but they can provide a lot of electrical energy during the day. But maybe during the day we do not need to so much energy. Then how is the actual energy come from or go to? How to deal with the actual energy? one solution is we will like this grid connect system. We will using the grid connect as a storage, and we will sell our solar power into the grid. But the grid has its own capacity. The grid has its own capacity. They cannot accept too much or too many solar cells. So in this case, I think the new development direction is using the storage energy technology, especially using the hydropower, because hydropower have a large grid scale. We can using the hydropower storing grid scale energy, renewable energy, and we can easily control to easily control the hydropower. Sometimes people, for example, if we can light the hydropower to store the actual renewable energy at night and at daytime, and at night, once we have a greater electrical load gap, we can using such a stored energy to supplement the gap. That is one reasonable and scientific way to use the renewable energy. So if everyone said that renewable energy is very good, yes, renewable energy is very good, but it is uncontrollable. That's a problem. Why I talk about this? Because we cannot expect the grid too much. The grid is very important, but the grid has its own capacity, limited capacity. You cannot sell too much uncontrolled renewable energy into the grid. The grid should have the grid normally have a very significant regulation and control. So that's a problem. That's some actual content of the renewable energy and the relation between the grid and the renewable energy. And the second feature of the advantage of the grid connected system is it can be particularly cost effective when the utility load peak and the solar radiation peak are well matched. This one is our condition. The condition is when the utility load peak and the solar radiation peak are well matched. When it is matched, then it is very particularly cost effective. But how about when the utility load peak and the solar radiation peak are not matched? So if they are not matched, then we need to use the grid as a storage to adjust to ensure the load peak and the radiation peak matched. Or we can use in the renewable energy energy storage technology for the renewable energy. So here we look at some problem affecting the grid connect system losses. The first one is the temperature effect, where we have discussed several times. The higher temperature means a low power generation of the PV solar cells, and the shading solar mismatch all about the, because as we know that the solar cells are grid connecting series and parallel to form a solar module. If there is a shading on one solar cells, this means either current or voltage or both of them will be affected by this shading and significantly reduce the power output, which has been mentioned in the previous slide of this PPT. And the third one is the non-optimal orientation and tilt. Sometimes we, especially for the wall side, PV wall or PV curtain wall, we cannot adjust the orientation and the tilt of the PV module. But for the rooftop system, we definitely can adjust the orientation and the tilt. So as the student asked me before, there exists the optimal tilted angle, which is strongly closely to the latitude of the buildings located in the building location. So if the non-optimal orientation and tilt, definitely the power output will be not so ideal. And the fourth one, I don't think it is very important because it's a manufacturing tolerance and unrated output. In generally, along with the PV manufacturing has developed for nearly 30 years. I believe the manufacturer's tolerance on rated output is can be controlled in a very small range, so it will not be a big problem. The inverter efficiency, yes, inverter efficiency. I also mentioned inverter efficiency. Normally in the range of the 80 to 95, depends the quality of the inverter. But most of the inverter efficiencies are relatively very high. And the maximum power point tracking arrow modules does not operate at a maximum power point. This one is a very good point. Sometimes if the solar module cannot operate at the maximum power point, it's normally due to some interior problem. For example, there is some defects in the PV modules, which resulting great or large series of resistance or series resistance or shunt resistance of the PV module. Both of this one will cause the PV module cannot operate at the maximum power point. And the wiring and the downtime varying is because wiring has its own resistance. Some wiring will cause some resistance energy loss, not because of the PV panel, but because of the wiring. Okay. Here we look at the PV production by technology, different technology from 1980 to 2016. Here we see at the beginning of the 2080, almost greater than 90% of the PV production are fabricated by the monosilicon. See the light blue parts, but gradually it will reduce to about 35 or 37% in 1990. And in this period, the multi-silicon based solar cells gradually increases market share. And the third one is the thin film. As I said in previous PowerPoint, is the thin film, the CIGS CDTE, thin film solar cell with a flexible substrate, which has relatively low power conversion efficiency, but have a relatively good light or high temperature performance at relatively low expense. But in general, it dominates PV production silicon-based solar cell, or including the multi-crystal silicon or monocrystal silicon. And in 1960, along with we see in the period from the 1994 to 1994 to 2016, the multi-crystalline silicon market share is significantly increased and much greater than monocrystalline silicon. This is due to two reasons. One is the multi-crystalline silicon has very good there is a new question asked by Kamaru Ahmed. Is that right? Is manufacturer's tolerance means derated factor of PV module? If yes, then where is mentioned. Oh, if you let's say this problem is a very important problem, very interesting problem, not important. Normally, once we purchase the PV module, the manufacturer will assign a number here. Normally they will say 165 watt in peak, but this one, what is WP, water in peak, means the maximum output power of this PV module is 165, but this one is normally unachieved. No, so because maybe one in most of the operational condition, it will generate 160 watt, and in other condition it will generate 155 or 158 watt. Sometimes even lower. So there is a tolerance. There is a tolerance, but the manufacturer will indicate the tolerance of the total power output in the once they saw them, they will provide important provide some key parameter, including the power output. There is a tolerance. There is a tolerance about the power output in the power. So this one, let's say the problem is maximum tolerance means that the rated factor of PV module in some degree, yes, the manufacturer tolerance means that the rated factor of the PV module. Yes, if yes, where is mentioned, you can say it in the key parameter indicator will tell you what is the detailed tolerance. Yeah, normally it will be in the introduction manual. Yes. Okay. Did I respond to your question? Ahmed. Did I answer your question? Are you okay? Yes, thank you. Okay. And where we are, and the maximum power wiring daytime downtime here. Yes. So in general, we can see that multi-crystalline silicon and monocrystalline silicon have experienced a trend that the multi-crystalline increase and monocrystalline decrease. But let's see the thin film. The thin film significantly decreased, especially at the end of the 2016. This is because one reason is the thin film. The most advantage of the thin film is it's a low cost. But along with the technology development, the multi and monocrystalline silicon cost has significantly reduced. We cannot say they are cheap, but we can see the silicon-based solar cell is not as expensive as it in 20 years ago. The cost of the silicon-based solar cell significantly decreased, but we cannot say it is cheap, but it is not very expensive, which is acceptable by the most of the company or investment of the government. And another one is thin film has its own disadvantage, including the low power conversion efficiency, and they have obvious optical decay problem. These two are the key drawbacks or the key disadvantage of the thin films, which results it significantly reduced, even though they have a flexible substrate, but it is not the point. So, but multi and monocrystalline, one thing is that the cost of them are significantly reduced, and another one is important is that the power conversion efficiency of this silicon-based solar cell significantly increase. At first, if I remember, in 1980, the highest power conversion efficiency of the silicon-based solar cell is only 12 to 15%. At that time, it is a world record. But this is a commercialized. But this is a commercialized silicon solar cell. If you check the lab world record of the solar cell efficiency, the data is much higher, but there's a difference because the power conversion efficiency of solar cell in laboratory is typically we use a very small device to test its efficiency. They definitely will be higher than the module one, because the module one we have a lot of other energy loss. The overall power conversion efficiency is definitely will be lower than the solar cells in lab. So at that time, the commercialized silicon-based solar cell power efficiency is about 10 to 12%. But in today, in 2020, not 2016, the average power conversion efficiency of a commercialized silicon-based solar cell is around 20. After nearly 40 years of development, the power conversion efficiency has been doubled, but the price is even lower than the at the beginning. So if we consider the economic development of the how do you say it? Let me check. Inflation. If we consider the economic inflation, the actual cost of the silicon-based solar cell will be even cheaper than at the beginning of the 1980. So two reasons: one cost, one power conversion efficiency results the silicon-based solar cell increase the market share of the silicon-based solar cell dominates the production. So we can see the production of the three in 1917 is the thin film can be ignored, only 4.5 gigawatt, and a multi-silicon-based solar cell has a double scale, about 60.8 gigawatt. And we can also have a look at the PV industry production by regions, by different countries. China and then Taiwan. At the beginning, and yes, in 2005, and everyone is almost the same. And about in 2009, the China and Taiwan experienced a high increase. China and Taiwan experienced a high increase of the global annual production at the beginning, especially in 2009 to 2012, experienced a very high development. But compared to the Europe and Japan, they experienced a relatively low. This is because the China has very large manufacturing system and low technical barrier of the PV module. Everyone can participate into the PV module manufacturing if you have sufficient financial or money and labor. And but the key problem is, as I said in their life cycle assessments, the key problem is the silicon purification is the technical barrier of the silicon purification is very high, and a limited company can do it. But after the silicon purification to a high quality silicon ingot, the later process is relatively easy for the most of the people. So due to the China have a lot of very mutual manufacturers, they can easily participate into this PV module fabrication. So they can increase a very high rate. And however, compared to the country who first promote the PV installation, household installation like Japan and Germany, the total production of these two countries is not as high as before. One interesting answer for this trade is because most of the PV module fabricated by China has been exported to these countries. So they do not need to fabricate too much PV modules. They can purchase very relatively cheap PV modules from China, and they use it directly. And if you consider of this, all the pollution and energy consumption in China, and they can use the developed country like Japan and Germany, other European countries use imported cheap PV module made in China and use them to generate a green, clean, environment-friendly power during this operational period. And after this PV module discard, they will maybe, I'm not sure whether they will recycle this PV module or not. But for most of the heavily polluted stage are in China. So we should take care about this one. We should not only see the one period, operational period. Yes, it is clean and environment friendly, but we also need to take care about the fabrication process and the recycling process. These two processes have a lot of pollution and consume a lot of energy. 这个 ROW, I believe the ROW stands for the remaining of the world. So in the scale, I think the China dominates the PV module. And finally, we have 20 minutes, and we can give 10 minutes for question and answer time. And let's see the next content of this PowerPoint is different module technologies. The first one is the cell efficiency average is 6 to 9% for amorphous silicon solar cell, compared with the 11 to 15 for multicrystalline silicon and 30 to 19 for single crystalline silicon. The efficiency of the silicon crystal solar cells is even higher in this day. For average New South Wales conditions, modeled amorphous silicon array output was around 30% less than for silicon crystal. For crystalline silicon array, in general, definitely because amorphous silicon-based solar cell has a lower efficiency compared to the crystalline silicon solar cells. And but non-crystalline thin film, here the non-crystalline thin film normally is amorphous silicon or CIGS or CDT thin film solar cells, can be deposited on many different substrates, many different flexible substrate actually. Some flexible or transparent with smooth uniform appearance. Amorphous silicon has a light degeneration problem, 50% from initial efficiency. especially over first 3 months. This one is, I said before, and the light degeneration problem is a very significant problem for most of the non-crystalline thin film solar cells. 19% decrease for the first 3 months is very horrible decrease. Manufacturer will specify the grade efficiency, and sometimes they will not. Thermal annealing at a high temperature reduce light-induced degeneration. Light-induced degeneration recover performance somewhat. Not sure. Thermal annealing is a very mature technology, but I haven't seen any successful case applied to prevent the light-induced degeneration of the non-crystalline silicon solar cells. Here is some parameter of the commercialized solar cells, and for most of the key parameter is the module name, SunPower, Songyang, BP, British Petrol, Kyocera, and the efficiency is here. Temperature coefficient. Temperature coefficient means the percentage of the coefficient once increasing 1%. For example, we all know that the optimal operational temperature of the solar cell is around 25 Celsius degree. How about 26? If the temperature increases to 26, then the overall percentage will decrease to 0.38, which means this one efficiency is operated at a standard test condition with temperature of 25. And if we got 26 Celsius degree, then the Celsius efficiency will decrease from 17.7 to 17.32, and so on else. And technology is a single crystalline silicon non-standard junction. And the performance ratio production divided to the champion cell. Champion cell, which means the cell with the highest power conversion efficiency with the same structure and the material is about 72. I believe the champion cell is normally not commercialized, but it's a kind of the lab, the research solar cells in lab. So this one is overall some key parameter, for example, for us to see how to judge what is this mean in the future if you plan to study or install a rooftop PV system. If you want to purchase some PV module, you definitely need to know what is a key parameter or indicator of this PV module, and how to compare them. You need to know what is amorphous silicon solar cells, what is the key problem of the amorphous silicon solar cell, and so on else. And here see there are two kind of crystalline solar cell in black. This one means the black solar cell means a monocrystalline silicon solar cells, which has a relatively high cost and high performance, high power conversion efficiency. You see, and there are two distribution of the solar cells for a single crystalline silicon. One for schools connected by this bus bar. This one is actually the cathode, which is normally silver. Sometimes they just cutting circle. In circle means actually all the monocrystalline silicon after the purification, we got the silicon ingot. The ingot actually is a cylinder. After we cut the cylinder into thin slides, every single crystalline should have a circle space. But in this circle space, we will see that there's a lot of white parts. This white part is the area utilization ratio is not very good. So most of time we will cut these circles in monocrystalline silicon into the three, we cut into the close to square, like the one in left, and close more area can be used to absorb the solar cell for power generation. So the right one is the old design one. The most of the new design for monocrystalline silicon solar cell is in this one. Okay, and the multicrystalline is reflect the blue one, then show the blue light, and you can see the different, apparently different. This one is the monocrystalline black, and the multicrystalline blue and green, and we can clearly see the green boundaries, clear boundaries, and the carrier recombination will at the gray boundary will significantly reduce the efficiency, and this is why the most multicrystalline silicon has lower power conversion efficiency compared to the monocrystalline silicon. And the second one is the anti-reflection coating used for multicrystalline cells, because they have such disadvantage. We definitely want to improve the territorial power solid radiation inside into the anti-reflection coating. So we add anti-reflecting coating to improve the absorption of the light, to improve its power conversion efficiency. And the last one, the blue light, is reflected from the dielectric layer, which is designed to strongly absorb the light, which will be absorbed best by solar cells. So actually, this blue light is not from the silicon itself, but is from the dielectric layer to prevent to improve the absorption of the light, to improve the further improve its efficiency. So the most of this is a basic understanding of the silicon monocrystalline silicon and the multicrystalline silicon, the difference and their relationship. Okay, there is only 10 minutes remaining for us for questions and answer time. Any student have any questions about this course? So I'm very glad to give us a general talking about the BIPV and the solar cells itself, including its operational principle and so on else. And I'm very glad to answer any questions asked by students. And
Okay.
Okay. Hello.
No, thank you, Dr. Zhang, for your very informative and enlightening presentation. Now we will enter into the Q&A session. If you have any questions, please feel free to type in our chat box, and Dr. Zhang will be very happy to give you all the answers.
他们是不是不能开麦是吧？
他开麦会乱掉。 或者说有的那个网络不太。
Please type your questions in the chat window, and I can answer the questions one by one. And anyone have any questions? Anyone have any more questions? Yeah, yes. Please. What's your question? Kamaru Ahmed. Please type your question in the chat window. Kama?
Yes, Kamaru Ahmed. If you have any question,
Mono has
yes.
more efficient, but production of multi silicon is more. It's very easy. If you can you hear me? Every commercialized product has many factors will affect the market share of the one commercialized products. Yes, the mono has more efficiency, but multi is more. But production of multi is more. So you need to take a trade-off, because, for example, if monocrystalline silicon has about 5% higher than the multicrystalline silicon solar cells, but multicrystalline silicon solar cells product cost is only 70% of the 70% of the mono. So normally we will more consider about the cost of the products rather than its power conversion efficiency, because only 3 to 5% power conversion efficiency is not a big deal. So should we use multi for large-scale solar projects? Depends what kind of solar projects. If the purpose of the solar projects is for commercialized, I encourage the multicrystalline. And if the purpose of the projects aim to present a high power generation for 示范性项目怎么讲for a national displayed advanced demonstration of the solar cells, you can use monocrystalline. But not only monocrystalline, you have multiple choice, including the fixed or the solar tracking system. If you really want to demonstrate the high performance of such solar project, but if you just for a normal commercialized solar cell, just fix the multicrystalline silicon is fine. Generally, the cost of both of these two is not too high, but yeah, there's always trade-off. Not only depends on one affects. Yes. Did I answer your question? Come on. Is tandem solar cell commercially available? No. My research focus is about tandem solar cell. Tandem solar cell is very expensive, even though its power conversion efficiency is even higher than 50%. But the tandem solar cell use different semiconductor material. Normally, the tandem solar cells have two problems. One is the expensive semiconductor materials, and the second one is the junction between different semiconductor. The junction compatibility between different semiconductor, which will result in a huge series resistance loss. So in current stage, I don't think the tandem solar cell is available at this moment, but I believe it will be commercialized in maybe next 20 years if we got a cheap semiconductor manufacturing, because the tandem solar cells and the semiconductor is not typically silicon. It's gallium arsenide and it's a 3-phi semiconductor. It's very expensive. I know it very much. Okay. OK， 差不多了吧，彭老师？
好，那我们差不多。
OK， thank you so much。
再问。OK， thank you, Dr. Zhang, for your presentation and your clear explanation. I think this presentation give a full picture of the BIPV system. I think with the continuous development of new technology and the increasing demand for the energy conservation, emission reduction, I think the BIPV will become a new trend of solar power generation. I think this presentation will be very useful for our participants in developing the solar power in their respective countries. So thank you, Dr. Zhang. Thank you very much for today's presentation. And if you have any further questions, please do not hesitate to come to us. I think we can give all your questions to Dr. Zhang. I think he is very happy to communicate with you in the near future. Thank you, Dr. Zhang.
Oh, thank you. Thank you, everyone. Okay.
Okay. So that's all for our first session, and our next session will continue at 6 p.m. at Beijing local time. So see you there. Bye bye.
Bye bye. 咋打不出来？
好，张老师非常感谢啊，我们这一环节就结束了，非常感谢，好辛苦，
好，
好，再见，好。